Here's another problem. Here we have an overall vector called f, which has a magnitude of 8. We've indicated a 20-degree angle based on this reference line. Please try to break this vector into components. Break this vector into components, please. How should we interpret this dashed line? Well, we're supposed to interpret this as being parallel to the y-axis. It certainly looks like it's parallel, so by convention we can assume this is parallel to the y-axis here. So we're making a 20-degree angle with the y-axis. Well, we need to draw a right triangle that indicates the components, and we know that this side here is going to be the hypotenuse. This is going to be the hypotenuse because it's the overall vector. Now, how do we draw the legs? Well, we know we want one leg that is parallel to the y-axis. So that leg is certainly going to be along this dashed line. We already know the dashed line is parallel to the y-axis. So I'm just going to draw this in now as the line that the y component is going to be on. And in order to make the picture come out nice, I'm not going to take a firm opinion yet on where that y component is going to end. Now I need to draw the x component parallel to this x-axis. So I need to draw a leg here that seems like it's parallel to the x-axis. And I know it's come out right if these two legs end up about perpendicular to each other. Remember that because one leg should be parallel to the x-axis and one leg should be parallel to the y-axis, since the axes are perpendicular, the legs should end up perpendicular. Now I can erase this portion of the line that turned out not to be necessary. Let's go ahead and label that this is f sub y. This is the y component because it's parallel to the y-axis. This side is f sub x. You can see that it's parallel, or maybe anti-parallel, to the x-axis. Before we go on, we need to put in arrows. Oh, you know, I realized I forgot one thing. I forgot to remind you that the first thing you should have done was draw the positive directions. So I hope that you started, as usual, by drawing the positive directions. I should have mentioned that at the very beginning. All right, going back to where we are right now, we're looking at our legs. Well, what are the arrows on the legs? Well, remember that as a kind of notational trick, we might say that the overall vector is starting at this initial point and pointing to this final point. The overall vector is pointing away from this initial point and towards this final point. And the components are supposed to represent the overall vector. So the components should also be pointing away from the initial point, or towards the final point. So this y component here has to have the arrow over here, because this is the direction that is away from the initial point. This is pointing away from the initial point. And the x component should have the arrow over here. You can clearly see that this arrowhead is pointing towards that final point. All right, I hope that this notational trick that I've introduced in the last couple of examples is making it easier for you to find the correct directions of the arrows on the components. But if that's not working for you, you better find something that works for you, because it's very important to find the correct directions of the components. Let's put an asterisk to indicate that this was the side we were originally given, and this is the angle that we're focusing on and that we were given. We can label our hypotenuse, the overall vector. F sub y is the adjacent side, and f sub x is the opposite side. Looks like we're ready for trigonometry. To find the adjacent side, we use the cosine. Because of cut, cosine refers to the adjacent side. Our adjacent side is being represented by f sub y, but we're just focusing on magnitudes and lengths. The hypotenuse is 8, and we need to multiply that by the cosine of 20. We're still just trying to figure out the magnitude. Using our calculator, we would find that 8 times the cosine of 20 is 7.5. I don't put a sign on this because this was so far just the magnitude. But now as our final step, I have to figure out the sine component without the dot. Now we decided ultimately that f sub y was pointing down and to the right, but our positive y direction is up and to the left. Well, that means f sub y is negative. Remember that the convention is that your axis points in the positive direction. Since we showed the y-axis pointing up and to the left, the convention is that up and to the left is our positive direction. The convention usually is that we don't even bother drawing the negative direction. We just draw the positive y-axis. Obviously, if the positive y-axis is pointing up and to the left, it doesn't take a genius to figure out that the negative y-axis is pointing down and to the right, and this component was pointing down and to the right. So f sub y is negative 7.5. Let's build that into our sketch. Time to work out the opposite side using the hypotenuse and sine. So, sine refers to the opposite side. The opposite side has a length which is the magnitude of f sub x. Hypotenuse was 8. Still working with magnitude. 8 times sine 20, approximately 2.7. Now, we're not done until we figure out the sine component without the dot. Let's see, our positive, well, we've shown the x-axis pointing down and to the left. That means the positive x-axis is down and to the left. But the x-component was pointing up and to the right, anti-parallel to the positive x-axis, so the x-component is negative. F sub x equals negative 2.7. Of course, on a normal problem, we'd also have to include the correct units. For example, if F stands for force, the name of the units happens to be newtons. You may or may not have learned about that yet. But in these videos, I want to just focus on components and the mechanics of that, and I'm not really worried about the units. On the other hand, we are super worried about the signs. Remember that if you got everything right about this problem, but you got the wrong signs, you blew it. You got to get the right signs. So keep doing this problem until you can get everything correct, including the signs.